Today in the AWS Developers Podcast, we're talking about GitOps. Good morning, good afternoon, wherever you are on this planet. Thank you for subscribing, to listen, to download the weekly episodes of the AWS Developers Podcast. We talk about all things developers related and sometimes AWS related. Not only, but today is the case. We're going to talk about GitOps and GitOps on AWS. And I have the pleasure to welcome someone that you hear already on this podcast. It was with Dave and Linda about a year ago, if I remember correctly. Johannes Koch, you are AWS DevTool hero, user group leader. Some of our listeners maybe saw you on stage already talking at an AWS event near you or not, or you are also... you also have a YouTube channel, so you're very active on social media, talking about all things related to automation, infrastructure, CI/CD, and these type of topics. Today, you propose to talk about GitOps. What is GitOps?
Yeah, thanks for having me, Sebastian. For me, GitOps really means the idea of having everything that you need for your deployments in Git, and all of your deployment pipelines and triggers also started from Git.
But we talk about infrastructure here, not the application code.
Oh, well, we can talk about both. GitOps can contain both. GitOps is more practice, and it can contain infrastructure as code as well as application as code. But it depends on how your team is actually going to set up that.
So as soon as I have code, any type of code in a Git repository, and I automate the deployment of that code from Git, from a Git commit, a Git push, or a pull request, I'm doing GitOps?
Well, maybe it's not as simple as that, but I think it's a good starting point to explain it like that. And maybe we can start looking at what is the simplest way of doing something GitOps like. The simplest way for me is you as a user, as a developer, you push something to a Git repository, and afterwards an automated process kicks off that deploys your infrastructure as code or your application as code up to your production environment. That is kind of already a flavor of GitOps. But GitOps, I think, includes way more than just that deployment and that automation. So maybe let's try to unwrap that a little. Let's start maybe with looking at one of the new things that AWS announced last year around having a possibility to trigger CloudFormation deployments from Git. And I'm going to start with that because I think this was an important announcement, an important new feature, as it brings people that have traditionally not thought about having your infrastructure as code stored in Git. It brings them to think about how to do that.
So this new feature is the ability to trigger a CloudFormation deployment from Git directly without anything in between, because we can do that since more than 10 years on AWS, but typically we need at least EC2 or CodeBuild or something, CodePipeline. But now there is a direct link between CloudFormation and Git. So I can git commit, git push, and have my CloudFormation template run.
Yes, exactly. And more importantly, there's so many teams and so many users out there that are still doing the traditional ClickOps approach, which means going to the console, creating infrastructure, and having something compiled there. But then you never know what the current state is. It's always complicated to understand where you are. So the possibility to export CloudFormation from an existing part of infrastructure component, I think that already exists for a while, then taking that CloudFormation, just putting it into a Git repository somewhere and updating and deploying your CloudFormation stack based on changes to Git, that already gives you a lot of transparency, and it gives you a lot of understanding on where you actually, what kind of changes have been done to the infrastructure. So that really levels up your operational footprint is my take on this. So this combination is really good.
So that's one of the benefits of GitOps. It's the ability to trace the change, who changed what, when, and what is the diff between the previous version and this version. But it's not new. 10 years ago, I was delivering AWS architect class in front of customer. And when we were talking about CloudFormation, I say, your CloudFormation template must be version and put them in Git. You have your data center in Git, and you can have a difference between V1 and V2 of your data center.
That is true, but we have matured a lot on what deployment strategies means these days. Last time I was on the podcast, we talked about the concept of CI/CD and making that the first part of your software development lifecycle. I think GitOps takes this a little bit further because it also helps you to think about how do you integrate all of your SDLC process within the pipeline and within all of your deployments, because you really always know the current state of your infrastructure is in Git. The current state of your application is potentially in Git. Based on where you actually deploy or the way you actually push something to a Git repository, that will also be transferred to your deployment later on. And I think that is, for me, a little bit more than what we did 10 years ago.
Mm-hmm. And this new feature from CloudFormation is super interesting. And as you said, it's a very good starting point. You have a Git repository. And when I say Git, it's GitHub, GitLab, Bitbucket. And then you have CloudFormation on the other side. But I guess for real-life application and enterprise, the deployment process is a bit more complex than just running a CloudFormation template. You might have running a temporary environment for a test. You might have a manual approval. You might have an ETL to fetch data from. So, what's the real life topology of a pipeline?
Yeah, that's a great question. I think there's hundreds of different possibilities and hundreds of different tools. As you already mentioned, for version control, we have at least 5-6 bigger players these days. On AWS, there is today the possibility to integrate. So let's say the simplest implementation is CloudFormation Git Sync. Then the next kind of level would be using Amplify V1, Amplify V2. Both has the possibility to have a standard pipeline that brings deployments up to somewhere. And then you have CodePipeline and you have CodeCatalyst as two additional options to implement something like GitOps in today's AWS world. CodePipeline, especially V2, got some great updates that allows you to also implement branch-based GitOps now, because you don't need to have a pipeline per branch anymore. You can now have one pipeline that then recognizes branches. That was a feature that was longly expected. And that also enables you to do a little bit more, a little bit better implementation of GitOps and gives you all of the flexibilities that you at the end need. If you're not as bored as me, maybe into AWS, you could, of course, also use traditional GitHub Actions to implement something like GitOps.
A GitHub Action hosted on GitHub or hosted on EC2 instance? It doesn't matter, actually. It's just a matter of where the secrets are.
Even better, hosted on CodeBuild is something that is also pretty cool now. So you run GitHub Actions runners on CodeBuild as well.
I didn't know that. That's cool. I will have a look at that.
I have a video on that as well. And that is, to be honest, is one of the cooler things as well. I think it doesn't really matter which tool you choose to implement GitOps, to be honest.
Exactly.
GitOps is most common in the Kubernetes world because it kind of works best if you have declarative infrastructure as code, which kind of Kubernetes also enforces. And there's tools like Flux and Argo CD that empower you to not think about the state of your Kubernetes cluster anymore, because they sync up that Git changes with the state of the Kubernetes cluster at the end. Now, why does this work well in Kubernetes? Because most of the Kubernetes services are kind of stateless. So that works very well there. GitOps works also very well for serverless services on AWS that don't have that much of a state. But I think
like when you need to replace a Lambda function, a step function, these type of things. Okay.
Exactly. And I think it gets a little bit more complicated to implement if you think about stateful resources like databases, maybe things like that. And that's something that I think we need to get better at as well.
Yeah, that was one of my questions. I know CloudFormation quite well and the derivative around it, like the CDK and others. When you change an attribute in a CloudFormation stack, the documentation clearly say this attribute can be changed in place. So without replacing the resource, we just update something like, I don't know, a timeout on a Lambda function, for example. But some attributes, when you change them, it actually deletes the resource and create a new one. If it is a Lambda function, it's not dramatic because, as you mentioned, it's stateless. But if it is a file system like an EFS file system, if it is a database, a DynamoDB database. We don't want that. So how the enterprise that are using GitOps are separating concerns between stateful and stateless services?
Yeah, I think you're talking about a point that is proposed by a lot of best practices, which means separating stateful from stateless resources in infrastructure as code, if you're able to do that. With that meaning, if you have a part of your GitOps repository, GitOps structure that is responsible for stateful resources, you might not want to change that as often to avoid replacements. And then you have a separate part of the GitOps structure that contains the stateless resources. So that's kind of something I've been advocating as well, as try to separate that out. If you have different CloudFormation stacks, that would be the best way from my perspective, because then you can trigger updates for one stack and just don't trigger updates for the other one. That avoids that problem. In general, I would say that as GitOps means to start from Git, we also need to ensure that there is a workflow around that or a pipeline around that. And this then can mean that if there is a stateful resource that is being changed, I maybe need an additional approval. Or I might need to have a trigger for someone to look at this before it actually gets rolled out. But that's something that needs to be implemented based on your business requirements at the end.
This is not related to GitOps, but how enterprises are doing it, they typically have like infrastructure as code for the most foundational part, which is probably the network, then another group of infrastructure as code for the database, then one for the application, and have multiple CloudFormation stack like that, or maybe different technologies as well, probably owned by different teams for very large enterprise. That's what you observe in reality?
Yes. And I think that it's also modularization of infrastructure as code at the end.
So it means that we can have traditional IAC, I mean, not triggered by Git, for the network and the stateful part, and then GitOps just for the serverless and the stateless part?
We could potentially combine that. I think for me, GitOps implementing GitOps is especially also a mindset shift for the relevant teams. It gives you the possibility to ideally not give anyone access to the AWS accounts anymore, because you just control all of your infrastructure and everything that you deploy from your Git repository, which also means that if there is a pull request approval, Johannes and Sebastian have been clicking on the approve. Now the change from another person is just going out automatically, right? That gives me the possibility to look at the state of infrastructure that is currently deployed, maybe on my main branch. But that's a mindset shift, because you need people to understand that approving a pull request means I have now just updated a production environment. And I think that's something that not all teams are currently doing. And a lot of, especially operations organizations, are also frightened of.
I like what you said, saying it's a mindset change for the developers. And that shows that in your mind, the DevOps methodology, it's perfectly integrated. Is it really developers, or are we talking about people managing the infrastructure, or should it be the same person in a real DevOps spirit?
That's a good question. I don't know. I think we have been struggling in the community defining what a DevOps engineer is, defining what a full stack engineer is, and talking about the different roles and responsibilities that today's engineers, cloud engineers, might have. So I traditionally, I try to not differentiate anymore between what is a DevOps engineer, an operations person, or developer, because for me, we all need to gain the skills required to all our to host our applications and services. And this also means we need to have a bright set of skills that everyone has to be able to understand everything that is part of the application or the service that we own. And then we might have a specialty as part of that. And that's where I think there is no full stack engineer from my perspective. There is no cloud engineer. There is no Java engineer, no front end, no back end engineer, because we all need to gain broader skills to be able to help with different parts of the deployment and application. That's a developer for me in the cloud world.
That's the 10 times engineers that we can read about at different places.
Maybe, yeah.
You said something else that is interesting. No human needs to have access to the production account, and only the pipeline has the permission to actually act on that production account. But that means that your pipeline becomes like the most secure IT asset you must have in your organization.
That is true. That also means that all of the automated processes that I have need to be evaluated even more than they were before. And we also need to start protecting that even more. I think traditionally, in a lot of organizations, people have been having access to production environments and have been doing changes maybe over there or implementing changes. And all of them were most probably manually driven or manually initiated, either through calling a GitOps workflow or calling a Jenkins pipeline or something like that. Now we give away that control to someone else, right? We give away that control of infrastructure to the pipeline. So we really need to trust that very well. And I think that's where we need to get a little bit better at. And to be honest, none of the GenAI capabilities that I've seen has targeted to make that portion better. Everything is currently centered on how do we improve developer experience and how do we make that life easier? How do we generate code and that kind of stuff? I would love some generative AI capabilities that help us understand that complex thing a little bit better going forward.
About the infrastructure and the relationships between the different components in our infrastructure. But when I was younger, I remember I SSH to a Solaris server in production and VI /etc/ I don't know what. And this is how we did change in production. Of course, we test the change before in different environment. Back to my training days 10 years ago at AWS, I was also advocating immutable infrastructure. You don't change infrastructure. If you need to change something, you create a new infrastructure. So you don't update the configuration of a server. You just delete the server and create a new one. When I'm listening to you talking about automatic deployment of infrastructure triggered by Git and workflows, it's a natural fit for immutable infrastructure. I mean, it's probably easier to implement immutable infrastructure with a GitOps methodology.
Yes, I think the concept of immutable infrastructure is supported by GitOps in general. I think it also gives a lot of possibilities to emphasis on that. Once again, stateful versus stateless resources, that's a big issue here, right? Because immutable stateful resources, I think, do not exist. But in general, I would say, yes, that is what you need to do. That also gives you the possibility. I think that's one of the last pieces to mention around GitOps is the possibility to roll back to a best known state. In GitOps, that could traditionally just mean revert the last commit if we do things right? Because then we would just get rid of the last change and would automatically once again roll out the previous version of the configuration as code, of the application as code stored in your Git repository. So I think that's one of the last pieces that are important to talk about GitOps, that possibility of rollback as well.
Without having complex change, you just tear down whatever has been changed and recreate a new resource as it was configured in the previous commit or the one you want to revert to. That's something we do at Amazon. The service teams, when they deploy something, they deploy through a pipeline, and the pipeline will automatically revert to the previous version if something is going wrong. That means implementing a lot of alarms and monitoring. We need to have a lot of observability. When do we know that something is wrong?
Yeah, exactly. And I think, once again, going back to the GenAI conversations of 2024, I think having support for that part of the rollout process would be something where we could all learn from what other organizations do, right? Having a dedicated model for CI/CD decisions, something like that, would be amazing in this case, I guess, I think.
What are the typical metrics that we should observe to decide to roll back deployment, especially if it is automatic? It has to be rock solid. So I'm in my mind, I have two types of metrics to observe. One is user-facing, like if we take Amazon.com, it's the number of orders that we receive per minute. If it drops, usually it's not because customers don't like us anymore. It's because they cannot buy. There is something preventing. And then there is the whole thing of technical metrics like memory, CPU, bandwidth, whatever. In your experience, what enterprises are using, or what combination they are using?
I think it's always a combination of infrastructure alarms that you need to have and application-based alarms. The application-based alarms are always based on your custom metrics that you need to implement for your application. And with that, you also then implement the rollback strategies if something goes wrong. At least that's the way I've seen it around.
It's a matter of maturity as well inside an enterprise to be able to deploy new infrastructure automatically from a Git push, or to roll back. That's even, for me, that's even more mind-blowing. Roll back a change and go back to a previous version of the infrastructure. From the customer you're working with, what's the percentage? I mean, are we talking about just a few selected, like the elite company, the biggest, most mature in cloud adoption, or is it something coming more and more frequently these days?
I'm not actively working with customers in this case, but I'm listening to the community and seeing a lot of people actually adopting GitOps and GitOps concepts worldwide. Especially right now, my day job has been bringing me towards using specific tools that empower GitOps, that even take this a little bit further, right? So,
for example,
for example, a combination of Flux or Argo with Crossplane, where Crossplane takes over the responsibility of managing your infrastructure for you based on a declarative model. That is kind of one step further to what we already discussed. You don't have a traditional pipeline anymore. You have Crossplane taking over the responsibility of bringing up infrastructure for you based on the declarative issues that you have. And that has brought me to have a lot of interesting conversations with people that adopt that processes and these kind of processes at the moment. So I'm seeing more and more people in my bubble interested in adapting these models because of that. And here, one last comment on Crossplane. Crossplane here really then takes the responsibility of bringing up AWS infrastructure for you. So you don't ever think about, do I now need an S3 bucket, or do I need whatever, right? Do I need a Lambda function? Crossplane manages that for you, kind of intransparently. So you really need to trust that tool. You need to trust in the person implementing that process, that it will do what you want, and that it will not betray you somehow. And I think that's a big important thing. And the next evolution of that is then something I think you had on your show already about infrastructure from code, with people like Jeremy Daly doing that and Winglang doing that as well. That's another thing where you then also need to trust that creation of infrastructure based on some application configuration that you do. And Crossplane takes that same thing at the end for the deployment strategy for you.
You're talking about defining a semantic, and it's the tool that implements that semantic into a specific service. In your case, it was an S3 bucket.
Yes, exactly.
It means these tools can be used across multiple cloud providers as well, or they are very specific to one cloud provider?
So today I am not aware of any tool that is able to do a traditional multi-cloud deployment, but Crossplane has the capability to enable you to deploy into different cloud providers. Now, what it does not give you yet is the possibility to have an abstract version of something that will then, based on your decision, be either on GCP, Azure, or on AWS, or any other cloud provider. So that's something that I'm still waiting for, kind of the meta resource language definition across different cloud providers, where we then have the mapping from the different services in an automated fashion for us. Right?
But there is a risk if such tool propose that type of abstraction above cloud provider, there is a risk that they only propose the most common denominator against services across the different services. So you cannot really use the specifics of S3 or Lambda that makes it different.
That is obviously true. There's always a risk, but I've been seeing more and more enterprises interested in building multi-cloud implementations and getting rid of that vendor lock-in thing. right? That ties you to a certain cloud provider. To be honest. And that's the same for our CI/CD in traditional pieces, right? I don't know if I told you, but I've been working with Torsten on a project called Progen Pipelines, which actually tries to get rid of the vendor lock-in in CI/CD pipelines. And I think that kind of stuff is going to be getting a little bit more love over the next month, in the same way that we have seen CodePipeline and Code Catalyst allow the possibility to integrate with GitHub, GitLab, Code Commit, Bitbucket, all of those things, like opening up that ecosystem. I think that's something that is gonna that is something we're gonna see as well going forward.
I don't like to talk about vendor lock-in. It's more about cost of switching. But to your point, what is the lock-in or the cost of switching for CI/CD? It's in the workflow definition, the famous YAML file, which is not exactly the same between GitLab and GitHub Actions, for example, or CodePipeline.
Yes. They're changing that, and then also changing the integration points. So it's not only changing the YAML file; it's also changing where do I store my secrets? How do I manage access to AWS accounts? How do I set up the roles? How do I set up that connectivity? If you change the tool, you always need to implement the changes as well.
Yeah, the execution itself is well known right now, thanks to Docker and container. True. It's pretty easy to move the execution from one platform to the other. It's more like the configuration of the platform. Okay, so you explain us what is GitOps, what are the main benefits. We talk about some of the challenge as well. You convince me. Where should I start?
Where should you start? Start with what is easy for you. Start with a simple implementation of if you commit something to Git, that gets automatically deployed. That will then hopefully take you towards adapting a specific tool or specific implementation, which will then help you to, on top of that, start implementing additional processes, either for verification or also for automated promotion to other things. So start with just you commit to Git, it lands in your production environment. That's maybe the first thing. Then you might add security and integration tests. Then you might add those metrics and alarms that we talked about a little bit earlier. And then you can move forward to more advanced GitOps practices where, based on a specific commit message, certain actions are going to be happen. Based on a specific comment in the commit message, only certain parts of the app infrastructure will be updated, and these kind of things. These are all advanced things that you're going to implement later as you mature through that process, I would say.
You also repeat several times that GitOps works better with declarative infrastructure as code. So as a recap, declarative is when you declare what you want to have, like a CloudFormation, for example, a JSON or YAML file. Imperative is more like when you program with the CDK, you have to, or with Terraform, am I correct?
Terraform can also be seen as declarative in this case, and CDK also has a declarative state, which is when you actually create so you do a CDK. What is the name?
Generate to
generate or whatever, right? Exactly. Synthesize is the name. Exactly. Thank you. And that's where you kind of generate that declarative state. So the part before that is imperative, but then it becomes declarative in the point of time when I decide this is a version of my infrastructure from or infrastructure as code that I now want to roll out. In this moment, your infrastructure as code becomes an artifact. And in that moment, it is also then declarative because you can always go back to that. Obviously, if you do that, you need to implement that part within your GitOps strategy as well, right? So where is that immutable artifact that defines your target environment? That's what we need to find out.
That's a good point. I never thought about CDK like that. But you're right. At the end, CDK generates CloudFormation templates. So it's declarative and you can version control that result of the execution of the CDK. So what is a real imperative then for you?
I'm not sure if that exists in infrastructure as code, to be honest. Maybe Winglang is a good idea into that direction, right? And there's others that do similar things, but maybe that's as close to imperative as possible because I lose access to changing the infrastructure below. But yeah, sorry, that's the best answer I have so far, Sebastian.
I like to close the conversation typically with a prospection of the future, where the industry is going to in terms of GitOps. What are the trends you're seeing as you're living and breathing this type of methodology since multiple years? What are the trends you're seeing now?
I think what we're seeing is especially going to be a little bit more visibility into what is actually done and triggered through GitOps. I think today a lot of the tools that support GitOps make it easy to execute stuff, but they don't make it easy to understand what is happening behind that and what actually will change if you do that Git commit. So I hope for more support on the observability side of the whole GitOps and automation processes that you have, with making it easier for me to grasp what has been changed, what is being updated, and what is the result of something that I did. We have seen some people trying to implement, let's call it an approval based on GenAI input in your CI/CD pipeline. And I would hope to see that kind of stuff coming a little bit closer, right? And giving me as a I'm going to use the developer name, going to give me as a developer more insights into what did I break with this commit and how do I fix it? And that's kind of where I hope that we're going to see a little bit more, because that will embarrass GitOps even more, I would say.
And to explain that in a human understandable way, not a cryptic error message coming from a subsystem somewhere. That's why you see a GenAI for.
Yeah, exactly. So yeah, putting the power of what we as a community have learned over the last decades, putting that into the fingertips of a workflow executed through different tools and different pipelines, potentially making that accessible. I think that's where I see a lot of value coming in the next years. And then also that will help to convince CIOs, CTOs worldwide to adapt these processes without the fear of GitOps breaking something in production, because that's the fear that we all have, right? So that's why we have change management boards still in a lot of organizations where changes need to be discussed before they get approved. And that's a mindset shift. No, that's just a pull request approval going forward. We don't have that change management board anymore. And we might need some kind of security approval for some of the changes, but not for all of them, because we trust the systems that we have built. And I think that's where I hope that AWS is doing that in a very good way already, and I hope that other organizations can follow that.
But can we continue with a change management board that inspect the change before doing the merge?
Yes.
That's a way to ensure that the traditional process still works with GitOps.
Yes, exactly.
But
we can do that.
But the idea is to automate.
Yeah, the idea is to not be frightened anymore. Don't be frightened of changes. Infrastructure or applications in the modern world have constant change, and we need to see these kind of changes as they just happen, and we don't want to really think about them, and we trust the tools that we have built.
Don't be afraid for changes. That will be the summary of this episode. Thank you, Johannes. You will be at the AWS Community Day, September 17. It's in Germany. In which city in Germany?
Yeah, we're running a community day in Munich. I'm part of the organizing team there. We're looking to see over 600 people that are very AWS focused and AWS centric, with I think 28 talks of very cool speakers that talk about real life problems. And that's going to be in the week before Oktoberfest. So if you're coming in on the 17th, you can just prolong your stay over the weekend and then also enjoy Oktoberfest on the weekend if you want to do that.
So it's in Munich.
It's in Munich, exactly.
München, Germany, and the talks will be in English.
The talks will be in English, yes, and we're going to have a lot of AWS heroes coming over, and a lot of AWS community builders speaking up there, and yeah, looking forward to see the community and bring everyone together.
So mid-September, 17th of September, if you're around in EMEA, in Europe, somewhere around Germany, AWS Community Day Germany, and as usual, the link to the event and all the other technology and tools that we talk about are in the notes of this podcast.
I'll correct you. It's not Germany, it's DACH. because we have Austria and Switzerland as part of this as well, because we're working as a community together. I think that's important to note. But would love to see you there.
I'll check my agenda. Thank you. Thank you, Johannes Koch. You are AWS DevTool Hero, user group leader, community day organizer. Thank you. We talk about GitOps. What is it? What are the benefits? What are the main challenges? How to get started? I hope this conversation was useful for you. Thank you for having listened to this episode until the end, and see you next week. And now go build.